problems? Well, prevention is first. We recommend that you use a toolkit obtained directly from NAIF and intended for your specific environment, platform, OS, compiler, and compiler options. Be careful about 32-bit versus 64-bit hardware. Use a current toolkit. Newer toolkits may have bug fixes and new features that you need. Toolkits are always backward compatible, since you have no problem with linking your old applications to the latest toolkit. Read the pertinent documentation. Tutorials, module headers, required reading technical reference documents, comments inside kernels. Use the correct kernels. Often, but not always, this means the latest version. You heard Boris comment that for S-clock kernels, the correct version is not necessarily the latest version, it's the one that's compatible with the C kernel that you're using. Verify that the contents, time, coverage, and intended use are suitable for your work. Comments in the kernel should indicate that. If you're using a Fortran toolkit, ensure your text kernels all use the line termination appropriate for the platform, which is line feed on Unix, Linux, OS X, and carriage return line feed on Windows. Using the bingo utility from the NAIF website is one way to make the change. To make the change is one solution. Be sure the last line of your text kernel ends with an end-of-line termination character. Avoid common implementation problems. Verify use of the correct time system for your need. That is, do you need TDP, UTC, or S-clock, or TBT? When using S-clock time tags, be sure to form your S-clock string to match the specification within the S-clock kernel. Make sure the fractional part is the form that's expected. This is something that trips people up. Sometimes the least significant field is mistaken for a decimal fraction. In fact, you probably shouldn't say fractional part here. It's the least significant field. So be sure that all fields of the S-clock string are compatible with the actual definition of the format. Verify the correct reference rates are used. Sometimes there are choices that may seem equivalent, but they might have significant differences, so it's important to actually identify the exact frame that's needed. For example, moon principal axis versus moon mean Earth versus IU moon. Also, there could be names that are somewhat similar that can be confusing. IU Mars is a body fixed frame, Mars IU is an inertial frame, centered at Mars. Check definitions of geometric quantities, planetocentric versus planetographic versus planetogenetic coordinates, oblate versus spherical body shapes. Check aberration corrections, converged Newtonian light time plus stellar aberration, light time plus stellar aberration, light time only or none. Target orientation corrected for light time or not. And don't confuse an instrument reference frame ID with the ID of the instrument itself, the object ID. We have a list of common problems, probable causes, and solutions encountered by users in various toolkits. Refer to the problems.html required reading. These are both provided in each toolkit package, or access the HTML document corresponding to the supported language at the NAIF website. This is for Fortran, C, IDL, and MATLAB. Some online tutorials include common problem section near the end of the tutorial, and it can be useful to read these documents before embarking on extensive SPICE-based programming projects, since some problems are best solved early in the software development cycle. So this last point is very important. It's much easier to get set up properly and avoid problems than it is to just wing it, try to get your program working fast without thinking about all of these issues first, because you end up doing a lot of debugging typically in that case. Some of these points, going back here to these definitions, a lot of times problems are caused because an initial problem specification is simply not complete, is not specific enough about things like which coordinate system is used or which time system is used. You can start programming without actually being sure exactly what problem you're trying to solve. Also, inputs coming from other colleagues might not be clearly identified. It might not be clear what time system they're using, what coordinate system they're using, and so on. So getting all of those inputs completely specified is really important. And yeah, aberration correction is a third item in that category. Somebody can, for example, ask you to compute something without telling you what aberration correction you need, and depending on what correction you use, you can get results that either are or not appropriate. Okay. For troubleshooting, if you can't solve a problem on your own and you need help from Dave, that means after, I guess, Mark has given up. Please include this information. We certainly will want to know the SPICE or operating system diagnostic messages that you observed. We'll need to know the name and version of the operating system you're using, the name and version of the compiler or programming environment that you're using, the toolkit version you're using. Hopefully it will be the latest one. If it's not, that alone might be the cause of the problem. Names of the kernel files you're using, include any meta-kernel you're using, and if the kernels are not available to NAIF, we may need to actually obtain your kernels. Also the inputs to the SPICE modules that signaled the error, and you'll be able to find out from the traceback message that you got what call you made to a high-level SPICE interface routine that led to that error. And if possible, a code fragment from where the error seems to occur. Now you can start off with perhaps by contacting us without this code fragment, but we'll definitely want to know the diagnostic messages you got and all of this version information. That's really basic. Please send email to only one person on the NAIF team. In any case, please do not separately send email to each of us. If you send email to one person, it will get routed to the best person to answer the question.